So we have the topic for today. We have the Earth and the solar system. Today we'll discuss about the concept of the light year and the evolution of the stars, the cycles of the star, how stars evolve. So first start with the concept of the light year. This we have already discussed this part. So today we'll discuss about the stars in the universe. So what is the concept of the light year? Light year is actually a distance traveled by the light in 1 year. How much distance? How much distance the light cover in 1 year? We call that as a light year. How we'll know a 1 light year equivalent to what distance? So we can. This is exam point of view. You should be able to convert the light year into meters or kilometers. So we have the formula that speed is equals to the distance divided by time. When an object is not accelerating, when an object is moving at a constant speed, then the formula is speed is distance divided by time. So if I need the distance, what will be the formula for the distance? If I need the distance. So speed is distance over time. If I need the distance, how I can find the distance?
Speed multiplied by time.
So it means the
That's
distance
speed
will be
multiplied by time.
equals to speed multiplied by time. That will be the distance. Now, what is the speed? Because when we are talking about a light year is a distance traveled by light in 1 year. What is the speed of a light in a vacuum or in air? It's a slightly different, but we consider it's approximately same. So what is the speed of a light in air? So speed of a light in air is 3 into 10 to the power 8 meters per second. 3 exponent 8. Now, because the light year is a distance traveled by light in 1 year, so what is the time interval? Time interval is 1 year. But because this is meter per second, so we want to convert the time into second. So if you want to convert 1 year into second, so 1 year, how many days are there in 1 year?
365.
365.
So we have 365. So we have 365 days. We want to convert them into hours. So what I will do, I'll multiply by
24.
24. The hours I want to convert into minutes, I'll multiply by 60. And minutes I want to convert into second, I'll multiply by 60. So the exponent 3 exponent 8 multiplied by this time in second. What is the final answer? When you multiply 3 exponent 8 with 365 times 24 times 60 times 60, what is the answer in meters? What we get? 3 exponent 8.
1.536 multiplied by 10 to the power of 6.
3 exponent 8 means 300 million meters times 365 times 24 times 60 times 60.
Three, 3 into the power 10, 10, 13. 10 to the power 13.
30. No, you all are doing a mistake there.
13.
No, it's
That
not
is-
correct. 13. The correct answer is 9.5 exponent 15. This is the right answer. Multiply 3 exponent 8 with 365. So it is 9.5 into 10 to the power 15 meter. So this 9.5, it's actually like 9.47 exponent 15. So 9.5 exponent 15 meter, what we call this distance, we call that as a 1 light year. So 1 light year is equivalent to 9.5 into 10 to the power 15 meters. This is a very important number. You have to memorize this. You should learn that 1 light year is equivalent to 9.5 exponent 15 meters. If I want to convert into kilometers, how many kilometers? So to convert the
10
meter
power
into
12.
yeah. Light year is actually a distance traveled by light in 1 year. So why the unit we got in meters? As you can see, when we were using a formula, light year is actually a unit of a distance. And distance is what? Distance is speed multiplied by time. What about the speed of a light? The speed of a light is 300 million meters in 1 second. So this is meter per second. And what about the time? It's about 1 year. So when we convert the 1 year into the second, so it was 65 times 24 times 60 times 60. And that was in second. So this second will cancel with second. And what we are left with? We are left with meter. So that's why when our final answer is there in distance, what was that answer? It was 9.5 into 10 to the power 15 meter. So this 9.5 exponent 15 meter is also known as the 1 light year. So 1 light year is equivalent to 9.5 exponent 15 meters. Is it clear? This concept of the light year? So light year is actually, so is that for a light to travel only? No, it's not the light to travel, go and return back. This is not the concept of a light year. Light year is a distance traveled by light in 1 year. Like example, say this is the source of the light. So this is the source of the light, which is emitting out light. And the light started, and after 1 year, you found that the light is here after 1 year. So how much distance the light will cover in 1 year, what we call that as a 1 light year, which is equivalent to 9.5 into 10 to the power 15 meters. And how we work out this distance? Because we know the speed of the light and we know the time, it's 1 year, and the speed is 300 exponent 8. So 3 exponent 8 multiplied by 365 times 24 times 60 times 60. So when you multiply all of them, you get the distance. And that distance is actually equals to 1 light year, which is 9.5 exponent 15 meters. Is it clear, the concept of a light year? Anyone having a doubt or a question in this?
No, sir.
Any doubt?
No,
Okay.
sir.
Now, just to compare, like to understand the concept of a light year, some examples you can see here. This is just as an information, you don't have to memorize. Like example, between the sun and the earth, it's 8.3 light minutes. Like it takes 8.3 light minutes to reach us. Like that's a distance. Like the distance traveled by light. Light year is a distance traveled by light in 1 year, but light minutes means it's a distance traveled by light in 1 minute. So it is between the sun and the earth is about 8.3 light minutes. But if we want to convert this into meter, how we can convert? 8.3 light minutes.
Speed divided distance divided by speed.
So I have the formula, no, not with 1,000. We have the formula speed is distance divided by time. So if we need the distance, the distance will be speed multiplied by time. So how many light minutes are there? How you know light minutes? So the speed of a light is 3 into 10 to the power 8. And now the time is in minutes. So you'll have 1 minute. 1 minute will have how many seconds? It will have 60 seconds. So you'll just multiply by that ratio. But usually they don't ask you to convert the light minutes. They usually ask convert light year into meters. So how to convert? How we can convert the light year into meter? As we know, 1 light year is equivalent to 9.5 into 10 to the power 15 meters. So the Proxima Centauri, which is the closest neighboring star to us, like to which is the closer neighboring star, which is 4.3 light years away. So how much distance it is away from us in meters? So 1 light year is equals to 9.5 exponent 15 meter. So if I want 4.3 light years, how much will be the distance? The distance will be x. So what we do, we just cross multiply. X will be multiplied here and 4.3 is multiplied here. So 4.3 multiplied by 9.5 exponent 15. What's the answer? 4.3.
Sir, 4.085 multiplied by 10 power 16.
So 4.3 times 9.5. So 4.1 exponent 16. Okay. So if we want to convert for 4.08 exponent 16 meter, it's written here. Yeah. How we can convert the light year into meters? So what is the rule here? If we want to convert, we have the formula that we know the relation that 1 light year is the distance traveled by light in 1 year, which is equals to 9.5 into 10 to the power 15 meters. That is 1 light year. So the nearest neighboring, the closest star, that is the Proxima Centauri, which is 4.3 light year away. So if it is 4.3 light year away, if we want to convert, so 4.3 light years is equivalent to x. We just cross multiply. So what is the value of x here? As you cross multiply, so value of x will be 9.5 exponent 15 times 4.3. So when you multiply this, you will get 40.1, 40.08 or 40.12, someone would wrote, into 10 to the power 16 meters. So that's the distance between us and the Proxima Centauri. Is it clear, this conversion?
Yes, sir. Sir, what will we call this conversion?
This is a unit conversion from a meter to light year. Or light year to meter, I mean, because light year was given. Same way, no, actually Proxima Centauri is not included, but the idea is, it's not about, I'm saying you learn what is Proxima Centauri, and it's about the idea that how you convert the units. So same thing, the center of our galaxy, the Milky Way galaxy, the center of the Milky Way galaxy is about 26,000 light year away from us. Means if the light travel start from Earth, it will about cover a distance which it will cover in 26,000 years. So if we want to convert into meter, so how we can convert into meter? So we know the 1 light year is equivalent to what? It is equivalent to 26,000. Sorry, 1 light year is equivalent to what? It is equivalent to 9.5 exponent 15 meter. That's 1 light year. But if we want 26,000 light years, what will the value for x? So we just cross multiply. It cannot be exponent 10. It's impossible. Why? Because it's already exponent 15 and you're multiplying. So you will never get exponent 10. So it will be 2.47 exponent 20. So 2.47 exponent 20 will be there. That is the distance between us and the center of our galaxy. That is in meters. So if we take the exact speed of a light, so between the Earth and the Moon, if we compare how much time the light take to travel from Earth to the Moon, it take about 1.3 seconds. But when we compare from Earth to Sun or Sun to Earth, actually it should be from Sun to Earth, as Sun is a luminous object. It gives out light. It takes 8 light minutes. Between the Earth and the Mars, it take about 12.7 light minutes. So if you travel at a speed of a light, you will reach Moon within 1.3 seconds. If you travel at a speed of a light, you will reach Moon in 8 minutes. You don't have to memorize these values. You just have to learn the light year which is equal to 9.5 exponent 15 meter. That's it. If you travel to Mars with the speed of a light, you will take about 12.7 minutes. If you travel to Alpha Centauri, it will take about 4.4 light years. And if you travel to the far side of a Milky Way galaxy, you will take about 52,000 light years. What is the size of our Milky Way galaxy? When we compare our Milky Way galaxy, it's 100,000 light years. So what does it mean, 100,000 light years? So if a light started from one end of a Milky Way and it reaches the other end with a speed 3 exponent 8, so how much time it will take to travel? It will be 100,000 light years. But light year is not a unit of time. Light year is a unit of distance. So how much distance is there? What is the width of our Milky Way galaxy? So we know that 1 light year is equivalent to 9.5 into 10 to the power 15 meters. So 100,000 light years will be equivalent to x. We just cross multiply. So 100,000 means like 5 more zeros will be added. So it will be 9.5 into 10 to the power 20 meters. That is the length of our Milky Way galaxy. Is it clear, the concept of the light year? Anyone having a doubt or a question in this?
No, sir.
No, sir.
Okay.